In this video, we evaluate the integral of x by 10x. Its x change from 0 to pi by 2. You see that we want to evaluate this integral of the product of x and 1 by 10x. We know that 1 by 10 is cot, so this integral is equal to integral of product of x and cot x dx. Now we got the integral of product of x and cot x dx, and of course we want to evaluate it as x change from 0 to pi by 2. We want to evaluate this integral as x change from 0 to pi by 2. As x change from 0 to pi by 2, and we can see that product of two function. Now when we get product of two function, we apply product rule of integration that says integral of product of two function u and v is given by first integral of second function minus integral of derivative of first function, that is u dash, minus integral of derivative of first function, that is u dash, times integral of second function, that is integral of v dx, and this product has to be integrated once again. In this case, we choose u equal to x and v equal to cot x. So we need to evaluate integral of cot x dx. Cot x dx. Let's do it. Integral of cot x is integral of cos x by sin x dx, and that is equal to log of sin x, of course with base e. And so by product rule of integration, integral of product of x and cot x dx equal to first function u is just x, integral of cot x we just observe it to be log of sin x, minus integral of derivative of first function, derivative of x with respect to x is just 1, and then integral of second function, integral of v, we just observed it to be log of sin x dx. However, we want to evaluate the definite integral 0 to pi by 2 product of x cot x dx. How can we do it? Well, we just need to write the limit 0 to pi by 2, 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 x log of sin x, x log of sin x, minus integral 0 to pi by 2 of log of sin x with respect to x. Now we write the upper limit pi by 2, that's equal to pi by 2, and then sine 90 degree, which is 1, and log of 1 is 0, pi by 2 to be multiplied with 0, minus, when I write lower limit, 0 log of sine 0, but log of sine 0 remains undefined. Can I say that the integral cannot be computed? The answer is no. Even though log of sine 0 is undefined, it turns out that the value of 0 times log of sine 0, or rather the value of x log of sine x, can be computed as x approaches 0. So what we do? We apply the limit. Limit x tends to 0, limit x tends to 0, x log of sine x, minus we copy as it is, limit 0 to pi by 2 we copy as it is, log of sine x we do copy as it is. Okay, how much is this limit? For that, what we do is we apply L'Hopital rule. Once again, we apply L'Hopital rule or L'Hopital rule to evaluate the limit x tends to 0, x log of sine x. Now, if we want to apply the L'Hopital rule, we must get an expression of the type 0 by 0 form or infinity by infinity form. Do we get? So far, no. Can we get? The answer is yes. Limit x tends to 0, we write as it is. Limit x tends to 0, we write as it is. Log of sine x, as x approaches 0, sine x approaches sine 0, which is 0, and log of sine x approaches infinity. So somehow I want infinity by infinity. So we write x as 1 by x to the power minus 1. Okay, we get of the type infinity by infinity. So we can apply L'Hopital rule and maybe we can compute the value. Limit x tends to 0, we write as it is. If I want to apply L'Hopital rule, I just need to differentiate the numerator and the denominator. So let us differentiate the numerator and also the denominator. Derivative of log of sine x is 1 by sine x, and then derivative of sine x is cos x. How about derivative of x to the power minus 1? That is equal to minus 1 x to the power minus 2. Limit x tends to 0, we write as it is. Now, can we compute this limit? Oh yes, limit x tends to 0. Let's write this as x square by sine x. Oh, we got negative sign as well, and then cos x. Now limit of product equal to product of limit, so we can write this as limit x tends to 0 minus that, so we don't have to worry about x by sine x times limit x tends to 0 x cos x. This expression is tending to 1 as x tends to 0, and this is tending to 0, so the limit is 0. Okay, so we got the limit equal to 0. Can we find the integral now? So we can write integral 0 to pi by 2 product of x and cot x dx is simply equal to 0 minus 0 minus integral 0 to pi by 2 log of sine x dx. However, integral 0 to pi by 2 log of sine x dx is simply equal to minus pi by 2 log of 2. Zero minus 0 minus this integral, and this integral is equal to minus pi by 2 log of 2. You may say, how? Check out the description. You will find the link and you can click on that link and get the reason why is it that this integral is exactly equal to this integral 0 to pi by 2 log of sine x dx is exactly equal to minus pi by 2 log 2.